Okay, so next up on the program is Miles MacLeod from Twente University. He's an assistant professor in philosophy at the Faculty of Behavioural Management and Social Sciences. He has long experience in many publications on the philosophy of interdisciplinarity and many different disciplines and interdisciplines. The talk is titled Towards a Theory of Interdisciplinarity.
How do I bring it up? Oh, there it is. Good. So, yep, thanks to the organizers for inviting me. This has been really nice so far. So, my title is Towards a Theory of Interdisciplinarity. This is going to be a very, very small step towards theory of interdisciplinarity. And you might be asking straight out, could you even have something like a theory of interdisciplinarity? And generally my answer would be, no, you should be suspicious of anybody trying to talk about theories of interdisciplinarity. But I'm going to do something theoretical with the notion of interdisciplinarity, try and add a bit of theoretical depth to it, something you can get upset about and angry about, which would be, I think, nice to do today. So let's work along that pathway. So I want to start out with just some pretty common kind of collaborative cases, which I want you to look at. Firstly, a systems biologist using mathematical models of biological systems to uncover fruitful pathways for experimental investigation. Sounds great. Tourism industry, scientists, snow scientists, climate scientists, and economists choosing to predict the effects of climate change on the skiing industry by coupling legacy, well-established models from each field. Scientists and natural scientists sharing and integrated data on a problem using a multiple regression analysis. And business scientists given the role of collecting consumer data that engineers can use in a design process. There's not much description about what's happening in those cases, but there's a few elements that might stand out to you. One of them is there are some asymmetries there. For instance, in the last one, the business scientists, so I've dealt with case studies along this kind of lines, and the business scientists are kind of given these marginal roles, and the engineers really don't care what kind of theoretical interest the business scientists might have in that endeavor. They really don't care. They don't want to really know about it. They just want the consumer data to optimize their design. Okay, but I want to focus on what I see as an essential conservatism about how these practices take place and how practices in interdisciplinary collaborative contexts take place. And that means focusing on methodology. But here's this basic question which I just raised before. Can we have meaningful, fruitful generalizations about interdisciplinarity? And I think we're all in the business of trying to develop those kinds of things because that's, certainly as philosophers, that's what we're trying to do, but also sociologists, people from STS are doing the same kind of thing. So ID does on its face seem difficult to generalize about. It represents a multitude of different interactions among different fields, along many different dimensions. Fields or disciplines may interact in terms of problems, methods, data, theories, experiments, explanation, values, and beyond that in terms of a multitude of institutional and educational practices and even architectural ones. So what could we possibly have to say in general about all these very highly specific interactions that different fields might have? Further, of course, the notion of a discipline and a field is very hard to qualify. As even the notion of integration, although Michael is working very hard on that right now, but it is nonetheless strikes me as a difficult notion to get your head around, mainly because of these kinds of things. Can you use integration to describe in any kind of strong, meaningful way what is happening in any of these kind of different scenarios, such as integrating data or integrating models? Okay, so my goals are limited, but still substantial. An account specifically of structures or patterns we see in the methodological choices made in collaborative integration. And I'm going to focus on methodology here, which doesn't mean that I think institutional side or any social psychological side has importance. It does, but in some respects, I see this as a bit of an antidote to where most research is focused currently, which is more on the institutional side of interdisciplinary interaction. So I won't apologize for focusing on the methodological side in that respect. Okay, my empirical evidence is limited, so I'm mainly focusing on the environmental sciences here, and I accept any generalizations about ID have numerous exceptions. But if the theoretical support is good, then we would have reason, I think, to take generalizations seriously which go beyond the empirical evidence. That's my hope. And of course, I'm happy to hear from you, from your own experiences. And further looking more specifically at methodological choices might help us tell us a lot perhaps about what is relevant and what is not in ID context. And as I said before, methodological choices have not generally been focused on. Okay, So ID modeling practice in the environmental science. So I'm relying on literature analysis, interviews with a colleague of mine, Michiru Nagatsu, and categorization work from environmental scientists themselves, who are very interested in categorizing their interdisciplinary methodology, which should tell you something. We have found that rather than a broad swathe of innovative practices, most modeling interactions are framed around a limited set of broad but familiar modeling strategies. And I should note that I'm, again, another qualification, I'm solely talking about modeling practices here. So when we do this analysis, we find that we can categorize the modeling practices in environmental sciences along a few kind of broad categories, which we think are kind of relatively narrow. And I'll talk about these briefly. The first is a kind of data-driven or statistical modeling platform. Draws on heterogeneous data from different fields, but uses a statistical model to combine data from different fields. So different groups can turn up with their variables, can turn up with their data. If they're in scale, if there are no kind of scale problems, then they can put them together in a model. Pretty low-hanging fruit kind of modeling practice, you might argue, but also very inclusive. Integral modeling, this is where you have one kind of generic modeling platform, like a systems dynamic model or an agent-based model, in which, again, everybody can kind of participate as long as they turn up with their variables and can supply some kind of relationship to describe the interactions between their variables and other variables. Modular model coupling, which is probably one of the more dominant in the environmental science, is where each discipline turns up with a legacy model, their favorite model from their field, and they couple them together. They get them to feed information from one another, back and forth, until they can solve a problem which requires multiple expertise. And lastly, this very interesting case which we've looked at closely called substitutive model coupling, where you take established frameworks from two disciplines that both address a given set of problems in a similar way on similar scales, and you replace less accurate elements which one field has in their models, which are typically outside its expertise, with those from the other field, which happen to be better, happen to be closer to what that field works on. Okay, so these are the kinds of frameworks that are happening. So we argue specifically that these decisions about how to interact and combine these methods are not solely functions of institutional constraints, but are actually made with respect to the affordance of various methodological approaches which already exist, and the difficulties of certain cognitive constraints. So, and what I mean by cognitive constraints are things such as the following: methodological, conceptual incompatibilities, methodological gaps, opacities, methodological problems, if you like. Now, environmental science is rife with various kinds of methodological problems. One of the most substantial is different scales at which different fields operate in terms of model building and data collection. So model experiments or other data collection activities are designed and function at different spatial and temporal scales. And scale problems are difficult problems generally to overcome in sophisticated ways. So for example, economic models tend to work on shorter time scales, but larger geographic scales, regional scales, whereas ecological models might work on smaller scales, like even at the level of the farm system, but of course might work over longer operational time because ecological variables take longer time to manifest themselves. Different epistemic values, different standards of evidence, different standards of proper practice. So data-driven empirical approaches in ecology clash with the highly theory-orientated perspectives in economics. So data-driven approaches, something like linear regression, can be used in quite different ways by ecologists and economists. For instance, statistical regression has a very refined role in economics for the most part. So statistical regression is about testing for off-model relationships with respect to a given theory, whereas ecologists will use linear regression to build a model. That's something of an anathema to economists. Different non-epistemic values with methodological consequences, some of them quite deep, of course. The substitutability of natural and human capital can definitely divide economists from ecologists in deep ways. And fundamental philosophical differences, if you're talking, which we already mentioned before, which came up before. I think Leonard mentioned it, difference between positivism and interpretivism, which is really a really massive divide. And the artificial-natural divide, which again can separate ecologists from economists, and what you construe as natural and what you construe as artificial. Okay. Now you can go through each of these methods and you can try get to tell a kind of cognitive story about why these methods would have been selected in these particular instances. So for instance, if you talk about the statistical data-driven modeling frameworks, well, one of the great affordances with respect to cognitive constraints is they're neutral with respect to background theory to some extent. Now, I've already mentioned different fields interpret statistics in different ways, but there's a kind of large degree of neutrality about statistical methods. So there's no need to solve incompatibilities between the theoretical models you have. And it's somewhat social science friendly in the sense that as long as your social scientist, your sociologist is willing to produce quantitative results, they can participate in a modeling framework, statistical kind. Scales can be chosen within the framework flexibly, but they do have limitations, of course. Available data or data collection needs to be scale compatible. There's no deep level of integration between fields, so there's no use of legacy model from different fields or practices of analysis. And that purely data-driven methods are not easy to rationalize within all fields, including economics. And maybe some of the natural sciences too. I don't know what a hydrologist might think when faced with this, but I can imagine a hydrologist with a large set of theoretical infrastructure might have hesitation about getting involved in this kind of thing. Integral modeling, there's a kind of systems dynamic model. So these can be very, very complex, of course. You can throw everything you think is relevant into these kinds of models, and then you'll have a mathematical relationship which describes the individual interactions. And then, of course, this will be computational, so the computer will spit out what your predictions are. Since each module has to be written in the language of the framework, there's less to worry about the consistency of models that these frameworks are producing. So the modeling frameworks are kind of relatively neutral in that respect again. All scaling and linkage issues are expected to be handled up front. Somewhat standardizable, and there's always this interest in the environmental sciences about standardizing, which we'll talk about. Some interesting things about the systems dynamic models is they don't seem to be used often as collaborative platforms at this point in time. So they're often built by disciplinary groups and tend to be biased towards the discipline which built them. And so far, unfortunately, there are a few examples of frameworks being used beyond their respective development teams. Why? Well, I'm not actually that sure what the reason for that is. Yeah. Both the complexity of systems, dynamics, and agent-based models and their theoretical neutrality make them difficult to parameterize, validate, and interpret across disciplinary boundaries. That might be a methodological explanation of this, but I'm not entirely sure what's going on there. This, as mentioned, is the big one. So I mentioned before at the very start about these various environmental scientists getting together to work on a prediction about what would happen to the tourism industry given climate change, or how the tourism industry would need to adapt to climate change. And you get this massive coupled model structure, different models coming from different fields being joined together, lots of feedback relationships as the models communicate with each other, and then can calculate, or you can perform an optimization to get a good strategy for dealing with climate change. What's great about these? Well, the obvious one is, of course, there's no real modification of anybody's modeling practices. You just have to stick these things together, which is not trivial, which is not a trivial thing to have to do, but each participant can develop their components largely autonomously using model components which are familiar and well tested. It does allow space for very complex contributions with theoretical depth, so state-of-the-art contributions from each field. The integration is often, the limitations, however, is the integration is, of course, often ad hoc. Legacy models are forced to apply to a problem and may not be the best possible representation. And the component models work well as long as the model is exercised in the domain of its development conditions. However, when the model is packaged as a module, reused and recombined, then of course hidden inconsistencies can creep in. And scale problems do need to be addressed if the models are out of scale, which they often are. And that can be difficult, as can calibrating these things. If you're sticking 3 or 4 complex models together and you're trying to calibrate them to fit the data you have, it can be very, very complex. And so that's something that environmental scientists worry about. It's an interdisciplinary problem. How do I calibrate large sets of models joined together? And there's some kind of criticism of this kind of procedure. So Voinov and Schugert label these things integronsters, right? This thing is an integronster. Gives good technical answers, perhaps. Sorry, this thing. But no real insight into what's happening because it's so large and complex. Okay, and the last one is substitutive modern coupling, which is one I really like. So I mentioned this is a case where you have two fields which have roughly similar model building frameworks for solving a particular problem, in this case, harvesting of biological renewable resources. Economists have had a traditional approach, but it's been very simplistic in terms of their growth model, if we're talking about fish or forests or whatever, because of course economists are not experts on population growth within ecological environments. But ecologists have been very complex with respect to growth modeling, but have been very unsophisticated according to economists in terms of calculating the economic output, whereas economists, of course, have been much more sophisticated. So why don't we just cross out the stuff we're not good at and shove the pieces we are good at together, and then we'll have a much better representation, a much more sophisticated representation of our system. Again, it preserves most model building practices and standards, since the modeling components are well integrated. Also, feedback between components can actually be used to help better design components using information from across disciplinary boundaries, and that's what happens in these cases. So if the ecological model fails or has some kind of infinities or inconsistencies, then the economic optimization will actually pick it up, because economic optimization looks for extremes, right? It tries to find them, so it'll find them. And that's actually very useful. And it does offer platforms for building long-term collaborative practices. So this kind of infrastructure can actually be worked on further. More variables can be added in. Climate change, for instance, can be added in, and the collaborative relationship can proceed on the basis of a kind of modeling framework. Okay, but these things probably don't come up very often as possibilities. You need this kind of similarity between the methodological frameworks. Okay, so observations. Most of these methodological choices amongst collaborators are kind of conservative responses to constraints. So they involve mostly the reuse and repackaging of familiar known techniques anyway, that are often shared anyway, like multiple linear regression analysis. They involve minimal adaptation of background methods, values, and avoids substantial methodological innovation. Now, this is at odds with the expectation, which is common in the interdisciplinarity literature, that ID and TD interactions on complex real-world problems will spur methodological novelty and innovation. And that is a strong expectation. That one reason why we want calibration is we want methodological novelty and innovation. So, get to the last part, which is, well, how can we kind of give a kind of theoretical account of what's going on here? And this is where I turn to ideas from philosophy of science to try and understand this behavior that's happening in environmental sciences. Okay, so let me talk about some of them, and let's see how my time goes. Here's the one which I think is probably most important in this case. So on philosophy of science accounts of scientific practice, one notion that's become very important is the idea of a modeling template. So this is the idea that science and engineering work through the development of modeling or methodological templates, which are relatively idealized and simplistic to begin with, but become the foci of research. And they act as a kind of standardization point, okay, and help ground theoretical development. So everybody kind of knows what they're talking about by picking the same theoretical the same modeling framework, and everybody can work on it and communicate about it. And these templates can then be shared across disciplines, which often happens. So in the case of ID, we might argue that these structured patterns of interactions are playing something like the role of templates. That even though we're not in a purely disciplinary context, we're seeing something like disciplinary behavior. That environmental scientists are settling on ways in which they're going to interact in interdisciplinary contexts. So such templates are not simply shared, but they facilitate interactions and integrations. So they serve the potential purpose of ES of directing and grounding ID research. So researchers in ID context want standardization and categorization just as they want in disciplinary contexts. They want to see the same kind of thing happen. And that's very important because they do. They write papers about how do we standardize all this stuff we're producing right now. Okay? Which conflicts with this idea that interdisciplinarity should be this fluid space of methodological invention and creation. Okay, the other, which I'll mention here, is domain specificity, which comes out of cognitive science, which in a cognitive science terms is the notion that a cognitive system is domain specific to the extent that the class of objects and properties that it processes information about is circumscribed and flexible. And certainly there is some evidence from cognitive science studies of expertise and from STS, science and technology studies, that natural scientific and engineering expertise at least is often quite domain specific, and it depends on relatively stable environments. And one kind of reason for this is how you understand what a kind of scientific field is as a cognitive unit, well, if you take a very strong view, it's something like this, that a scientific field is a system of interconnected values, theories, modeling templates, tuned to generate functional results about a given domain. But any of these values, theories, modeling templates can become entrenched in such a system and hard to modify the more downstream dependencies it has. So if a particular epistemic value is playing a strong upstream role in your scientific system, then it's very, very hard to modify that or to take it out of the system. So modifications, innovations are expected to be wherever few downstream dependencies exist. And what does that mean? Well, I just skipped to maybe Lakatosh's idea here that when you're talking about scientific progress, most scientific progress in normal science comes through modification of auxiliary hypotheses. That is, the outlying hypotheses are where things happen. So is it possible that this is what we see in interdisciplinary contexts too? That if an interdisciplinary context requires some level of innovation, it's through environmental scientists agreeing to modify their auxiliary hypotheses, but certainly avoiding any hardcore theoretical assumptions. Okay, so towards a theory. So just 2 more slides and I'm done. So these various kinds of cases provide some theoretical resources for building a theoretical understanding of choices within ID collaborative contexts. But I think these all converge on some essential claims. So the stuff we can get angry about. That collaborative ID research looks to recapitulate the cognitive structure or methodological structure of disciplinary research through its concern with templates, slow, relatively low-level modifications in innovations, standardizations, and so on. And relations that characterize disciplinary development over time are also relevant to those that characterize how disciplines engage in cross-disciplinary interactions. Okay. And, well, isn't this obvious? I don't know. One reason why I bring it up is simply because of the expectations that people in interdisciplinary contexts often have around the notion that ID will generate substantial methodological innovation within short-term funding contexts. But these kinds of processes are more long-term processes, right? Building templates, standardizing, modeling, markup languages, and the like are not short-term projects, and they do require sustained investment. Okay, I'll finish there. Thanks.
Anyone? Does anyone have a question? Yes? Yep.
Interesting beginning of thinking of a theory of this. My question is, your example, there are quite clear, how should I call it, entities or you have these models from the different domains, and the interdisciplinariness is about merging them, having them work together. What if we, each of the contributing domains do not have any of these tangible results, if they have different theories to bring into the table? Is what you propose as a theory, what of that would be applicable in the case where you have less tangible results to bring into the table?
So there's some interesting questions about there. One question is, well, what happens outside modeling context in environmental science? And is that as fruitful as what happens in, or as productive as what happens in modeling context? I would say at present in the environmental sciences, a lot is coming out of the modeling context. So we step outside that domain and we ask questions about what is happening in those. That's not something I've studied, but I have a few intuitions. For instance, with the social science kind of ecology, economics interactions, they in my experience have been problematic, and they've been problematic whenever the social science researchers are non-quantitative. So if they're qualitative researchers, so of course they come with a theoretical perspective on how we should study social systems, but if they have nothing to bring to a kind of modeling framework, then it doesn't work. And it's not because it's their fault, I'm not saying it's their fault, but the ecologists and the economists are not really budging on that, on that aspect of things. That's what they expect. So, I mean, a short answer to your question is, that's something I certainly need to look at. What happens outside the modeling context, and whether it, in sense, replicates what's going on here. And it might be that this really only applies to kind of modeling practices. So this template theory is about modeling practices So template theory by Paul Humphreys, 2004, is about what happens within disciplinary modeling practices within disciplinary context. So maybe the story is different. Maybe there is more fluidity outside this context. Yeah.
Yes, we have another question.
Yes, Lennart Olsson from Luxus. It's about this modeling in environmental science. There was a report from NSF a few years ago showing there has been a tremendous shift in the funding from empirically based ecology, the ones that are out in the field,
right.
towards using mathematics and models. And they were quite concerned about this shift, especially since we live in a time when there are so dramatic changes out there that they are actually missed because people are just sitting inside and looking at the computer instead of looking what's going on outside. So from that point of view, I think I would be a bit more humble about the importance of modeling in relation to the more classical, empirically based ecology.
Yeah, so I'm not expressing a normative view about whether this is the right way to go.
Almost.
In fact, maybe almost. I mean, there's a number of ways to look at it. One of the things that you could say. Oh, by the way, this pattern is also happening to some extent in biology as well. That there is pressure to get into modelling, to do computational modelling, and the reasons for that are complicated, and they would certainly be worth looking at. I mean, some of it might be due to the fact that there seems to be more payoff, whether it's right or wrong, that comes out of these kinds of, harder modeling efforts. I mean, it's hardcore modeling efforts. I mean, it's just kind of tangible what they do. So maybe that's part of it. But as a normative side of this, somebody who's really, really strong about interdisciplinarity could look at these examples, almost all of them, and label them in very pejorative terms multidisciplinary. Right? The worst possible thing in the world. That they're not really interdisciplinary. So they're not living up to the expectations, sorry, where did I do with them? That we have of interdisciplinary work, because they're not essentially integrative in any meaningful way, right? So they're not living up. And in fact, if we were to produce really integrative work, then maybe you'd get stuff where the sociologists doing interpretive studies are integrated into the overall methodological structure. We don't see that. So from that point of view, this stuff doesn't look that good, right? It just looks like business as normal, carried on in a collaborative way. And in fact, one can ask the deeper question, which is I think all relevant to everything we've been talking about so far, is why do we prioritize collaboration in interdisciplinary context? We've already seen a lot of discussion about asymmetries and how these can really bias what happens in those kinds of contexts. There are other means through which interdisciplinarity can happen, of course. It can happen through hybridized researchers, which Lisa mentioned. And these guys tend to be very innovative in how they use the methodologies that they're given. They have some kind of deeper insights into what's going on when they become really effective with using those two methods. You can have people crossing boundaries, right? People from another field entering. And historically, those people have had much success in shaking established disciplines up. You can have imperialism, right? When ecologists decide that they're going to do economics and create a field called ecological economics, right? That's, whatever economists think about it, that's quite a methodologically innovative approach. So there's lots of other ways in which interdisciplinarity could be happen and could be funded, but we do prioritize collaboration, and it's not. And if with these kinds of results, which come out of collaborative interactions, is that really reaching our goals? That would be a kind of deeper question about this. I don't have an answer to that. Just raising it, because it's one of these things. Interdisciplinarity literature is full of basic presuppositions about what we think, and they're somewhat intuitive about what we think will really work as far as interdisciplinarity is concerned. And they're never really kind of examined in any kind of close way. But if we're going to think collaboration is the way forward, then we should have a kind of rationale for why we really think that's the best way to shake things up, if that's our goal. Yeah.
All right, thank you very much.
Thanks.